Okay, so our lesson for today is the electric field. Now, what is an electric field? We know what field means, right? It's like an open area where a field, an open area, a wide area, it's like that, just like a field, a literal field. Action at a distance is a force between objects that are not close enough for their atoms to touch. There's a distance, meaning they are separated by more than a few atomic diameters. For example, a charged rubber comb attracts neutral bits of paper from a distance via the Coulomb force. So that means the force there that attracts those pieces of paper is the Coulomb force. And it is not the comb, the rubber comb is not actually touching the bits of paper, but it attracts those paper at a certain little distance. Let's now talk about field, the concept of a field. A field is a way of conceptualizing and mapping the force that surrounds any object and acts on another object at a distance without apparent physical connection. So for example, as you can see, for example, a gravitational field, there's what we call electrical field, there's also a gravitational field. And by these two terms, we can actually say that in concept, they are similar. Though they are different from each other, because the other one is electric field, the other one is gravitational field, the fact that they are both field, they have the same concept. So for example, as you can see in the figure here, the field of the positive and negative charges, or this is what we call electric field. You can imagine it like an area where the force of the charges are or is present. A field where, kumbaga, ito, just like positive and negative. We know that positive and negative charges are unlike charge. That's why they tend to be attracted. That's why, as you can see also, these lines here are ano yung nangyari? Nagkakaroon ng connection because they are attracted to each other. Kasi nga, positive and negative, they are unlike charge. But this, the area that surrounds these charges is what we call the electrical field, where the force of these charges are present, as well as the gravitational field. Let's look at the bigger picture. Gravitational. So, syempre, andyan yung Earth. The gravitational field, that means the field when the gravity still is acting. So, for example, nandito yung airplane, still, or nandyan yung anything na nandyan sa taas, nasa sakupan pa rin siya ng gravitational field. So, kapag mahulog, talagang hihilain yan ng force of gravity. Hihilain talaga siya kasi nga yung bagay na yun na nahuhulog is still on the gravitational field where the force of gravity is present. I hope you can understand the concept because they have the same concept. If you understand the other one, you can actually understand the gravitational field, the concept of the gravitational field. Electric field definition. It is defined in such a manner that it represents only the charge creating it and is unique at every point in space. Specifically, the electric field E, we have this symbol, big letter E, or its its symbol, the abbreviation, or the variable we use for electric field. It is defined to be the ratio of the Coulomb force to the test charge, where E here is the electric field. Its unit is in Newton per Coulomb, since force is in Newton and charge is in Coulomb. force here is the electrostatic force or the electric force of charges, or sometimes called the Coulomb force, and in Newton because it is still force, and Q for charge, or letter C. Q for charge, and its unit is in Coulomb. Okay. Electric field lines. Now, what are electric field lines? It is a series of lines drawn from a point charge representing the magnitude and direction of force exerted by the charge. Since we're talking here about magnitude, at nakaakibat dun yung direction, that means electric field is a vector quantity. You still can remember in our physics 1, we have discussed two quantities, the scalar and the vector quantity. So when we say vector quantity, that's a quantity having magnitude and direction. If scalar, magnitude alone, without direction na yun. So, electric field, meron siyang magnitude and direction. And to visualize this magnitude and direction of that electric field, we have to look at its electric field lines. So, these electric field lines are drawings. Using lines to represent electric fields around charged objects are very useful in visualizing field strength and direction. Since the electric field has both magnitude and direction, therefore it is a vector quantity. Like all vectors, the electric field can be represented by an arrow that has length proportional to its magnitude and that points in the correct direction. So, it can be represented by an arrow because it is a vector quantity. If you still can remember, scalar quantity cannot be represented by an arrow because it doesn't have direction. Only the vector quantity can be represented by an arrow. So, yan. As you can see in the figure, in figure letter A, the electric field lines of these two charges are in repulsion. When we say repulsion, kasi nga, like charge, repel. So, yan, repulsion. As you can see, the lines are going into the other direction from each other. However, in figure B, unlike charge, attract, that's why the electric field lines also are attracting to each other or having connection, are now connected. That is because they are unlike charge. So they attract. Okay, so that's all. Thank you very much for listening.